Given an input stream of characters limited to A through Z, find the first non-repeating character every time a new character enters the stream. For example, let's go through a sample stream here. So we have A enters, B enters, C enters, A enters, B enters. So we have the first time a character enters the stream, the second time, etc., etc., etc. So when A enters the stream, the first non-repeating character is A. When B enters the stream, the first character with no repeats is also A. C enters, also A. When A enters again, the first non-repeating character with is B. And then when B enters, A has a repeat, B has a repeat at this point, so C is the first non-repeating character. Okay, let's get started with our algorithm. So we'll start with the function definition. We'll open it up. We'll set up two data structures that are going to interact in a really cool way to give us our solution very efficiently. So we'll use the built-in linked list class through C# that is a doubly linked list. It'll be a doubly linked list where the value that we're storing, or the data that we're storing, is a character named mylist. Is a new, let me try to fit this in so you can see it. Okay, so we've created a doubly linked list, and we will create a dictionary. I'll scoot this over for more space, where we're going to have a char and a node, which is denoted like this. Name it dict, and then we'll have to break to the next line to fit the rest of this. Okay, now we have our two data structures created. Let's show how we're going to interact with the stream. So what we're going to do is use a for loop to iterate over the contents of a string that we're going to input. The string will be called stream here. So for through the entire length of the stream. And so just to be clear, this isn't part of the solution. This is just setting up the interaction for how we'll take in the input data. So first we'll check if the dictionary does not contain the current character that has been inputted. So if it does not contain it, we're going to put it in. We'll create a new node. Called new node. We'll add the input char and the new node as a key value pair into our dictionary. And then we'll add it to our linked list. We'll add it in last position. So what we're going to be storing in the linked list is any time a character has only appeared once. So if the dictionary does not already contain the input character, then we're putting it at the end of the linked list and adding it to the dictionary with the location of the node. Else, that means that the dictionary does contain the key. We're going to remove it from my list because it's no longer a contender for being the first non-repeating character. And then we have to handle what are we going to print out. So one additional detail is if there are no non-repeating characters at the point in time that a new character is entering the stream, then if there are none, then we're supposed to print out -1. So another if statement, if mylist.count is 0, which means there are no characters that have entered the stream that are contenders for. There are no characters that have entered the stream that have not been repeated. That's a lot of negatives, but there are no non-repeating characters present if mylist.count is 0. Then we want to console.writeLine -1. Else we're going to console.writeLine mylist, the first element in the list. So mylist.first.value. Okay, so that's the algorithm that we've come up with here. Let's take a sample input stream and run through this, and then analyze the space complexity and time complexity. Okay, and then I'll also show you what's going on in the dictionary and in the doubly linked list. So I will set up, I'll cut this off and I'll do a key value and also a linked list, DLL. Right, so let's say our input stream is, let's do ABA for the sake of the time of this video. So our input stream is going to be ABA here. So for int I equals 0, I less than equals stream.length, I plus plus. These two data structures have been created as such. Now, if the dictionary does not contain the key for the stream of I, let me write out 0, 1, and 2 here. So I is currently 0. The dictionary has nothing in it. So we input A as our key here. Well, first, we don't add it to the dictionary first. First, we create a new node. Okay, then we add it to the dictionary. So here's A, and I'll denote this. This is storing the location in memory of new node, but how, I don't know the actual space that the machine is allocating for that, so I'm just gonna put node of A here for the value. And then mylist.addLast of new node, so the last element, we add that at the end, which is, right now, the end is the beginning because there's nothing in there. So we add A here. And if mylist.count is 0, no it's not, else console.writeLine mylist.first.value. That would be A. And let's have a, can you see that? Yeah, you can. Okay, console. And the console has first printed out A, which is great. Moving on to B. So if TikTok contains stream of I is 1, stream of 1 is B, dictionary does not contain B, so we enter this if statement. A new node is created with the value as B. That B is added as a key into the dictionary, and the node location of B is added as the value for that key, and then B is added last in mylist. Now we come down here, mylist.count is 0, no it's not, else console.writeLine mylist.first.value. A is still, A will get booted out in a second, but A has not gotten booted out yet since the current stream is AB, and A is the first non-repeating character in that stream. So here, mylist.first.value is A is getting printed out. Onto our last char, I is 2, stream of I is A. If dictionary contains A, it does, but not of that. So let me say that in a different way. if the dictionary does not contain the key that is A, it does contain that, else, we enter this else, mylist.remove dictionary, and the key is A, because I is 2. So we remove dictionary of stream of A is the value for key A, which is the location of node A, which means that node A is removed from my list. So node A here is removed from my list. Now, if mylist.count is 0, that is not true, else console.writeLine mylist.first.value is B. So let's double check with ourselves that that is the, oh, it got scooted. Console output is AAB. Let's double check with ourselves that that is the logical output we desire. And in fact it is. Our output was AAB. When A enters, A is the first non-repeating character. When B enters, A is still the first non-repeating character. When A enters again, now B is the first non-repeating character because A has a repeat. One last thing is to analyze the space complexity and time complexity for this algorithm. This has probably been my favorite solution that I've come up with so far, just because of how interesting the data structures were to work with and how the space complexity plays out. So we go back to the problem statement here, and we're given an input stream of characters that is only between A through Z. So let's think about this together for a minute. The keys that are being inputted into the dictionary are limited to the 26 characters A through Z, which means that the space complexity of the dictionary is constant. It's not O of n. And likewise for the doubly linked list, we're limited to characters A through Z, which is 26 characters, which means we'll never have any more. In worst case, we would have 26 characters in our doubly linked list, which means the space complexity for the doubly linked list is also constant, which means those are the only 2 data structures we're using, right? So our space complexity is actually constant. Time complexity, also constant. These actions that we're performing, let's see, creating new data structures, constant. Adding a new node, constant. Inserting to a dictionary, constant. Adding to a doubly linked list, constant. Removing a specified node from a doubly linked list, constant. And writing out to the console is constant. So our time complexity for this solution is also constant.